This LG DC inverter outdoor PCB is completely dead. It is not showing any kind of function at this time. I will connect the power and show you. Now I will place the multimeter here so we can check whether electricity is coming or not. Now I am turning the power on. The power is on. As you can see here, 229 volts are present. I have connected the probes here. Electricity has entered the PCB, but there is still no function or any kind of movement here. Now in dead PCBs, the very first point for testing is this fuse, so we will check the fuse in continuity mode to see if continuity is working or not. So, it is completely fine. There is no issue in it. The fuse is okay. Now if the fuse is okay, it means the chances of a short circuit are low, because if we physically inspect it, I cannot see any damage here. It looks completely clear. Let's also check its backside. As you can see, there is no kind of burn mark. Now, in this kind of situation, the PCB is studied to understand what system has been installed in it. If we look here, I will open it. I have removed the heatsink from here. Now there is some more clarity about what system is installed in it. Now this is its high side where the main electricity comes for the compressor. One bridge rectifier is installed here, which looks quite large and is clearly visible. But the system here is something like this. Let me show you. An SMPS is installed here, and the system for the SMPS is completely different. Let me show you here. The electricity for the SMPS is going from a completely different place, and this is its bridge rectifier, which I think is around 1 to 1.5 ampere. And ahead of this, the whole SMPS section is installed here. The remaining thing is that electricity is entering here. Our fuse is fine, and this is the line filter. After that, there's a 470 ohm current limiting resistor, which as you can see, is also going towards the SMPS. Now we have understood these things. So the very first testing will be of the high side, whether it is the SMPS or the compressor drive circuit. Its high side is very important because if it does not work, then the PCB ahead will not work at all. Or if there is a short circuit in it, then even in that case, the PCB will not work. Now here we will have to check all of these components so that we can know whether our high side is safe or not. So we check the bridge rectifier. We will set the multimeter to diode mode. The left side is the positive side, so we will place the negative probe on positive and the positive probe on negative, and then we will see the condition. I have placed the probes. Now I will change the polarity of the probes. Here the voltage drop is 0.466. On the second side, the voltage drop is 0.521. And on the third side, it is 0.516 voltage drop. So the chances are that this bridge rectifier is completely fine. After this, the next thing is this diode. So let's check it. It is showing completely fine. In the same way, we will check the IGBT. As you can see, no matter on which point or pin we place the probes, it should not show 0. If it shows 0, then there can be a short circuit. As you can see, we are not seeing anything like that here. Instead, it is showing a voltage drop, which means there is a chance that this is also fine. Next, we will check the high side of the IPM. These 1, 2, and 3 pins on the left side are all negative pins. After that, there are W, U, and V, then positive, and the last pin is unused. Now here I will place the probe on positive and the other side on negative. Here we are not getting any voltage drop. So now what we will do is change the probes. As you can see, the voltage drop appeared and then disappeared. Now again I will change the probes. We can check it by placing them anywhere. As you can see here, the voltages are now appearing. Earlier, they were not appearing on the negative pin, but now they are appearing. So voltage drops are coming on all 3 pins with the positive points, which means it is fine. Now let's also check U, V, and W. The voltage drop should be almost the same. As you can see, it is the same. So this is also completely fine. There is no problem in it. Now this PCB has 2 high sides. One high side is for the compressor drive, and the second high side present here is for the SMPS. Now, when I check the SMPS side, as you can see here, there is also a 3.15 amp fuse installed, which controls the SMPS. Now I will check this fuse here. As you can see, this is its backside. First, I will check the meter itself. Our meter is fine. Now I will place the probes on these points. As you can see, this fuse is completely fine. Now, one thing has been confirmed here. There is no kind of short circuit present here. Because all the fuses are completely fine, which means the chances of a short circuit are low. Now I will check this bridge rectifier for the SMPS. As you can see here, I will place the negative probe on positive and the positive probe on negative, and I will set the multimeter to diode mode. The voltage drop appears and then disappears, which means it is fine. In the same way, I will check the other points as well. The voltage drop should appear here just like I showed earlier. So this is also fine. There is no issue in the bridge rectifier either. Since this bridge rectifier looks completely fine with the multimeter, now let's move ahead and check its SMPS. Because if the SMPS is not turning on, or if the switching IC or some other component is causing an issue, then this problem can still occur. This PCB has a chopper installed with this number, and the switching IC number is 3A155D. Pin number 1 starts from this side. Now since there is no kind of short circuit in this PCB, we can directly apply electricity and check it. So I connected the power and electricity has reached here. I will set the multimeter to AC mode. We will check it in AC mode. So here on the AC side of the bridge rectifier, 224 volts are properly reaching, which is completely fine. Now I will switch the multimeter to DC mode and check the DC side, negative and positive. As you can see here, 297 volts are being generated on the bridge rectifier at this time. This means electricity is properly entering here. Now let's move ahead and see why this is not switching. This ground coming from the bridge rectifier is going to pin number 3 of the switching IC. Now here, pin number 1 is the source pin for overcurrent protection and signal input. Then after that comes VCC, where the operating voltage comes. The third pin is ground, and the fourth pin is the feedback option. Pin number 4 is attached to this optocoupler, which means the feedback generated here comes to this pin. And these 4 pins here are the drain pins through which the chopper or transformer installed here operates. High voltage comes here, and then low voltages are generated on this point which go for feedback. Different voltages are generated on these pins, because of which 5 volts, 15 volts, or 12 volts are being generated here. I have applied electricity again. Now we will check it. As you can see, this is our ground, and here directly around 300 volts are coming. Proper DC volts are reaching here. Now here, without an oscilloscope, we cannot properly check whether after switching the chopper or transformer point is turning on or not. So if we want to check it with a multimeter, then we can check these points. Now we will check this optocoupler to see whether feedback is being generated or not. First I will check the anode and cathode. Here I will check the DC voltage to see whether DC voltage is coming or not. I think this SMPS is working, so I will check the anode and cathode. Here, around a maximum of 1 volt is being generated. This means this optocoupler should be working. Now here, emitter and collector voltage should be generated, so I will take ground from here and check on its collector. On the collector, around 0.647 volts are being generated at this time. This means the optocoupler is also working. So this means there can be some issue ahead because the high side of the SMPS is working. So now I will turn off its electricity and discharge these capacitors so that no issue occurs. Now I feel that this chopper or transformer has a problem on its low side. I will check what the issue is, but I think there is something wrong here. Because voltages are being generated, but the PCB is not properly booting up ahead. So there are some diodes installed here. We will check them in diode mode. First, let me check this diode. It is giving a voltage drop. Now I will change the polarity and check it again. Yes, it is showing a 0.373 voltage drop, which is fine. Now let's check here as well. And as you can see, this one is showing a 0.094 voltage drop. This means this diode is showing an issue. Now let me check the next one too. This one is also fine. So these 3 are snubber diodes. What happens is that when voltages are generated, they stop the return voltage from disturbing the low side of the chopper and prevent it from coming back. But this diode here is showing 0. A capacitor is also connected with it, so I will remove this diode from here. This is the D010 diode. Now I will check this diode here and see what value it shows. If we look at its forward bias, it is showing a 0.393 voltage drop. Now we will take it into reverse polarity, and here also it is completely fine. So it is showing fine, but we will not be fooled by it. Now I will check this snubber diode. So let's see what value it is showing here. As you can see, it is the same. Now I will change the polarity. As you can see, it is still the same. Alright, if it is the same, then we will move ahead, because I thought it was faulty, but there is nothing like that. Now I will check the voltages here. The value of this snubber diode is the same, but now what we will do is apply electricity again. I will turn the power on and check the voltage in it, because I felt this one was weak, so I replaced it. Now let's do one thing. We will take ground from this point. Ground is already present here, and now let's check on this point of the snubber diode. As you can see, 5 volts are coming here. Now let's check the diode connected with it and see how much voltage is coming. We will take ground from here. Here, 17.76 volts are coming, so this is fine. In the same way, let's check this diode. Here, there is no kind of voltage present. Now let me show you what issue is happening here. This capacitor is connected with the snubber diode. When I place the probes on the capacitor, as you can see, this is why the snubber diode is showing a short circuit. Now, when I move further ahead, as you can see here, this capacitor is also showing short. So all the capacitors connected with the 5-volt line are showing short. In the same way, as you can see, this capacitor is also showing short, even though 5 volts and 17 volts are being generated. Now, as I went deeper into the PCB, look here at pins number 78 and 80 of the microcontroller. 2 capacitors were connected here. When I checked them, and after checking the meter itself to confirm it was fine, as you can see, both points are short. The next one is also short. Besides this, when I check the other capacitors installed here, as you can see, they are also short. So there are many capacitors near the microcontroller that are showing short. This means the microcontroller itself has internally become shorted. Although I even removed the capacitors, the short circuit still did not disappear. I wanted to repair this PCB, but right now it will not be possible for me because at this time I do not have another microcontroller available.
Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.